So here we're looking at 15.5, area between a line and a curve. This can also be the area between two curves, but the same principle will apply. So it is a similar idea to when you do composite areas at GCSE, but we just look at these two things separately. So we will have a curve, we've got a line. If I just go from that point where they are intersecting and draw the vertical line down, so I'm hitting 4 at that point and 0 is this limit here. So if we were trying to work out that green area, what I would do first is work out the area for the curve, which would include that triangle, and then subtract the triangle off. So you would go with the curve. So you've got your curve there, but we're only going up to 4. So when we do the integration between 0 and 4, we would get that area, and then I would look at the other area that I've got there, which in this case is the triangle, and we would take it off. You can integrate the line in order to get a triangle, but it is quicker to use a half base times height. Exactly the same, you might be required to use a trapezium. You could integrate if you wanted to, but a trapezium would be quicker. Okay, so it's just a case of get a good diagram, look at the areas that you are dealing with, try and get into your head you're going from curve down to axes, and then you should be able to build up what your subtraction needs to be. So let's have a look at this example first of all. So if we start with number 1, so there are quite a few steps that we need to take here. So the first graph that I've got is a quadratic, and it's a negative quadratic, and it goes through the axes, the x-axis at 0 and 3. So I've got a graph that looks like that. And then the other graph that I'm looking at is y equals x. So y equals x would go through like that, and we've been asked to find the area between the two curves. So in order to do that, I need to find where the graphs intersect. So I know that they intersect at 0, both of them went through the origin, but I don't know what that coordinate is there. So hopefully you are thinking, if I'm trying to do a point of intersection, that's simultaneous equations. So if we expand that first graph out, the quadratic, and then simultaneous equations, we set them equal to each other, which will give me the quadratic x squared minus 2x, which when I factorise it will give me x minus 2. So I know that my other coordinate here is 2. So what I'm going to do is I'm going to integrate this first curve, and remember it needs to be expanded out in order to be able to integrate it. So I'm going to integrate the first bit, the curve, between 0 and 2, and that will give me the area that comes all the way down to the x-axis. So when we substitute 2 into there, we're going to get 6. And then I put 2 into there, minus 8 over 3. And then when I put 0 into both of them, I get nothing. Don't skip that step there. So that gives me a total of 10 over 3. And that is the area, if I was to just draw it on its own, that is the area between the curve, the line, x equals 2 and the x-axis. So I'm now going to look at the area of the triangle. So I know that when from here, when I've got x is equal to 2, so the point of intersection, because it's y equals x, I've also got y is equal to 2. So if I look at the triangle and I just do it on its own, the base is 2 and the height is 2. So we've just got a half times base times height, which is equal to 2. So to get the final answer, we are doing 10 over 3, take away the triangle, which is going to give me an area of 4 over 3. let's have a look at number 2. So I want to do y equals 4 plus 3x minus x squared. In order to sketch that, I need to get that factorised. So I'm going 4 and 1 because I know I can make 3 from there, and it's going to have to be minus 1 and plus 4 to get a plus 3. So I've now got my points where that curve is going to intersect with the x-axis, and it's a negative quadratic again. So we're going through minus 1 and 4. I'm going to always label up everything you know while you're drawing the graph. Now, the other graph that I'm dealing with is 7 minus x, so it's a negative line, negative gradient line, and it's going to go through 7 on the y-axis, but it's also going to go through 7 on the x-axis. It is worth working that out so that you know, because obviously if it was cutting the x-axis less than 4, then I would have a completely different shape that I'd be looking at. So we're looking for that area here. And I know that those points were 7. And of course I knew that that was 4. So that helped me in terms of mapping that out. So I want to work out what these points of intersection are. Always draw your vertical line. So we just draw a vertical line because that's going to go, they're going to be the limits, and that will tell us what our area is going to be. So the first thing I want to do is simultaneous equations to find a point of intersection. So I'm going to take everything to the right-hand side. So we've got x squared minus 4x plus 3 and factorise. You'll find that a lot of these do factorise quite easily because you're not being tested really on the quadratics. It's just a tool that we're using here in order to be able to solve these. So we know that our limits that we're working with here are 1 and 3. So focusing on the quadratic first of all. So we've got the integral of 4 plus 3x minus x squared between 1 and 3. Over 2, minus x cubed over 3 between 3 and 1. I'm going to substitute the upper limit in first, so we put 3 in, so we get 12 plus 27 over 2 minus 9. And then I put 1 in, 4 plus 3 over 2 minus a third, which is going to give me 33 over 2, 31 over 6. So the area that we get for the quadratic between the x-axis and the quadratic is 34 over 3. I'm going to do the line here just because I've not left myself much space down there. So what we've got here is a trapezium. Doesn't matter what order you do these areas in, so you could have done the trapezium first. So we know that the distance across the bottom is 2, between 1 and 3. I know that when I have my values of 3 and 1, if I substitute that into the 7 minus x, then I've got 7 minus 1 is going to give me the biggest height, and 7 minus 3 is going to give me the smaller one. So the area of the trapezium is a half a plus b times perpendicular height, which is equal to 10. So the area that we are looking for is 34 over 3 minus 10, which is 4/3. You have in the notes booklets 2 exam questions that you need to have a look at. If you follow that method, you should be absolutely fine. So you've got the diagram drawn there. So you're going to find the points of intersection. So points of intersection, we do that with simultaneous equations. And then you work out the area from the top curve, work out the area from the bottom one, and then subtract them from each other. And that is it.